Hello everyone. Today we'll complete the remaining portions of our set theory word problems. We talked about two sets. We were doing the word problems of two sets. Let's continue from there. Exercise 5.4. Exercise 5.4. Question number 7. Question number 7. So after first we read the question and we determine that what is given to us, what are the symbols, values that is being provided to us, and what we need to find in symbol. So in a class of 60 students, 25 students play cricket, 20 students play tennis, and 10 students play both the games. Right? So we are talking about two sets. What are the two sets? First, set of students that play cricket, and the other set of students that play tennis. Agree? So if I talk about in case of Venn diagram, if I say first in Venn diagram, what happens? So cricket and tennis. 10 students play both, right? Now, in cricket, there were a total of how many people? 25. 10 is already sat, so 15 remaining. In the tennis circle, I want how many people? 20 people. 10 are already there, 10 left. And in total, in the universal set, there are 60 people. So I can see that including both cricket and tennis, there are a total of only 35 students. That means 35 students have chosen one of them at least. Either they have chosen cricket or they have chosen tennis. How many haven't taken anything outside 25 people, 60 minus 35? So this is a gist of what is supposed to happen in this sum. But when we are actually doing the sum, we need to do it with formulas and symbols. We can't do it using Venn diagram, right? So we'll first write the name of the two sets. Let C comma T be the set of students who play cricket and tennis respectively. So according to question, what is given? How many people play cricket? 25. So that is in symbol. How should I write that in symbol? The number of people in cricket, the cardinality of the set C is 25. Then 20 students play tennis. So cardinality of the set tennis is 20. 10 play both. What is both? Both is intersection. So
Intersection.
intersection T is 10. So I have C, I have T, I have intersection. What is the one basic thing I can completely and for sure find? Union. So we know N of C union T, number of elements in C union T, number of elements in C plus T minus intersection 25, 20 minus 10, 35. What is this 35? 35 is union. Union, how should I write it in the words? What are these 35 people? What are they doing?
35 people play cricket and tennis.
They either play cricket or they play tennis or they play at least one of the two sports. I can say anything. So how many people? Therefore, 35 students play at least one of the two games. And in total, out of a total of 60. What is 60? 60 is the cardinality of universal set. So if I want to now find out that if the two circles combined is 35 and there were in total 60 people, how many played neither? How many of them did not
60
play
minus
anything?
35.
60 minus 35? Higher number. So number of students who play neither sports We want to do 60 minus 35, right? That I already seen with from the Venn diagram, but I need to write it in the symbol part. So number of elements in the universal set minus the union, that became our formula. That is 25. Understood?
Yes.
Please try 8, 9, 10, 11. Question number 8. In a group of 50, in a group of people, 50 read newspaper A, 20 read newspaper B, and 10 read both. So let P be the set of people who read newspaper A, and Q be the set of people who read newspaper B. So according to the question, number of people who reads newspaper A, that is in set P, is 50. Number of people in set Q is 20, and 10 read both. Both is intersection. So what we want to find is at least one. At least one is union. So N of P union Q formula. N of P plus N of Q minus N P intersection Q. 50 plus 20 minus 10, that is 60. So 60 people read at least one of the two newspapers. 60 people read at least one of the two newspapers. Clear? Is it correct, everyone?
Yes, ma'am.
Question number 9. In question number 9, in a group of 65 students, 40 like cricket, 10 like both. How many like only tennis and not cricket? How many like tennis? So in this case, the 65 is not clear whether it is universal or union. But I have shortage of information. So I'm guessing that all these 65 students are somewhere or the other. So I'm taking it to be union. Yes, it's not clearly mentioned, but I need the answer. So 65 is union. So again, say A be the set of people who plays cricket, B be the set of people who plays tennis. A set of people who play cricket, B set of people who play tennis. So number of people who play cricket is 40, who plays both. Both is intersection 10, and let the union be 65, right? Union be 65, right? So first, using the formula N of A union B, A plus B minus intersection 65, 40, N of B minus 10, 35. So N of B means what? There are 35 people who play tennis. Therefore, 35 people play tennis. But now we also want who plays only tennis. Let's see. This is cricket, this is tennis. 10 people play both. Now, in the cricket part, there were a total of, in the cricket circle, there were a total of 40 people. I've already written 10, 30 remains. So these 30 people play only and only cricket. Now, in tennis, we have already found that there are a total of 35 people. Out of 35, already 10 are sitting. So remaining 25. Remaining 25. So these 25 people are only playing the sport tennis, right? So how will I get out of 35, remove this 10, I'll get the only part, right? So number of people, or number of students who play only tennis. What I want to do is, I want to subtract from 35, 10. 35 was set B and 10 was the common part, right? Became the formula. So 25. Basically, only tennis is what? Tennis minus cricket, B minus A. So 25 students play only tennis. 25 students play only tennis. Clear?
Yes, ma'am.
Yes, ma'am.
Question number 10. In a survey of 600 students in a school, 150 students were found to be drinking tea and 225 students were drinking milk. 100 were drinking both. How many were drinking neither? So, two sets are drinking milk and drinking tea. So, let a set of people who drinks tea, B set of people who drinks milk. So number of people who drinks tea is 150. Number of people who drinks milk is 225. Both is again intersection. Both is 100 people, right? So first we find out union because that's the one thing that comes to the mind as soon as we see these three data. N of A union B. A plus B minus intersection. 150 plus 225 minus 100, that is 275. So if I talk about the universal set and now the two circles. So drinking tea and drinking milk, universal set. Universal set has 600 people, common 100. So in the tea section, there should be a total of 150 people. 100 are drinking both. So there are only 50 people who drinks only tea. Out of milk, there are 225 people. Out of that, 100 drink also tea. So remaining 125 drinks only milk. So the total is 275. Now these 275 people are drinking something, either milk or tea. So how many people? There were total 600 people we asked the question. Out of that, only 275 people selected something or the other. So how many did not go for either one? So number of people, students who drink neither milk nor tea is will be what? Out of 600, remove 275. What is 600? Universal set. From that, subtract A union B. That is 325. 325. So there are 325 people who drinks neither one. Any doubts?
No, ma'am.
No, ma'am.
Now we are going to move to 3 sets. We'll move to 3 sets. So in 3 sets, what we'll talk about is we don't need a lot of formulas. Everything can be done with the help of Venn diagram. So let us first understand what happens in the Venn diagram of 3 sets. A, B, and C. Let us first, what we try is, let's identify first. Okay. So if I want A, I'll say A. If I don't want B, not B. Not B is what? B complement. I want A, I don't want B. So A, but not B. A and not B. Not B is what? B complement. So A intersection B complement. Agree? Whenever I say and, I say intersection. A is A, not B is B complement. So if I'm talking about this particular area, what is this area? The area that is common to all the three. the area that is common to all the three sets. This is known as A intersection B intersection C. Clear? If I want this, what will this set be? This will be common area between A and B. What will be this area now? It's a part of A and B, A intersection B, but it removes that part that it was sharing with C. Out of this A intersection B part, this was A intersection B, C was irrelevant. Now from this part, what they did is, they removed the part that they were sharing with C. So now in the third one that I've shaded, I have shaded the part which is there in A. I've shaded the part that is there in B, but I haven't taken the part that is there in C. So I want A and B and not C. So A and B and not C is C complement. Did you all understand? What will be this portion? What will be this area?
Ma'am, A intersection C.
A intersection B complement intersection C. I want A, I want C, but I don't want B. Yes or no? Yes. So if I now say this area, and this area, what will this mean? This is the portion which is present in exactly two sets. This portion is present in A and B, not C. This is present in A and C, not B. This is present in B and C, not A. So this is exactly two sets. Yes.
Yes, ma'am. Ma'am, I'm
Yes.
sorry to interrupt, but Pratosh wants to join the meeting under the name of Advait. He's waiting in the waiting room. He just
No, there's
called
no
and
waiting room.
No, this is exactly two sets. Any doubts still here?
No, ma'am.
No,
What
ma'am.
will be this
No, ma'am.
portion? What will be this portion? Guys, it is
Ma'am,
present in A. Yes. Is it present in B? No. Is this portion present in C? No.
mm,
Is this understood? Basically, this is only A. This is only A. Yes or no?
Yes, ma'am.
yes, ma'am.
Yes, ma'am.
What will this be?
Only C.
Sorry?
Only C.
Only C. Symbolically.
Yes, ma'am.
A complement intersection B complement intersection C.
Very good. I don't want A. I don't want B. I only want C. Yes? Clear?
Yes, ma'am.
Yes, ma'am.
Yes, Yes, ma'am. ma'am.
What will be this? This is the portion that belongs in exactly one set. Left side, only one set. A, here only one set B, here only the set C. So if I combine all of them, it means that the sets that are the elements that are present in exactly one set. Yes or no?
Yes, ma'am.
Yes, ma'am.
Exactly one set. How about if I take all of them? If I take all of them, that will be union of all the three. Yes or no?
Yes, ma'am.
Yes, ma'am.
Understood?
Yes, ma'am.
Everybody understood?
Yes, ma'am.
Yes, ma'am.
Okay. So once we have understood this, we'll now move on to a formula. There's only one formula here. We don't need any more formula than that. Okay. So union is also known as at least one of the two set, or either A or B or C, right? So whenever we see the word at least, that is union. So for three sets also we use a formula. Okay. So now see, if I want to find that A union B union C, please understand first. You are all clear with the notations, right? So I took the entire A. Then I took the entire B. And then I took the entire C. So what I did is I took A, I took B, and I took C. I took all three of them. But is it correct if you see the diagram? No. Why? Because there are so many portions that has double colors, right? High and up. So this portion, what is this portion? A intersection B intersection C. How many times have I noted? How many colors are there? There's a yellow color, there's a red color, there's a pink color. There are three colors in this portion.
Yes, ma'am.
In this portion, I'm saying. There are three colors. Now, if I remove this and I talk about as a whole this part, how many colors are here? A intersection B only I'm writing. Two colors only. Pink and yellow, green. Right? Right? Similarly,
Yes.
B intersection C I took twice, and C intersection A also I took twice. These portions. Right? So what I'm doing is I've counted so many things so many times. But when we are counting the sets, we only take everything once. So I've counted thrice. Now these I've counted how many times? Two times. So I'll subtract one time. Minus n of A intersection B, B intersection C, C intersection A. Right? But when I did that, right? When I did that, I removed the green portion from here. Okay. Right? Then I also removed the pink portion from here. Right? Agree? And here, these red portions got removed. So what was the problem that arose? See, earlier these three common part was counted thrice. Now when I subtracted A intersection B, when I subtracted this part, so all the three common part got subtracted once. Then when I did this part, I subtracted A intersection C. So again, all the three common part got subtracted twice. And then when I subtracted B intersection C, this common of all the three got subtracted one more time. So earlier I counted them thrice with ABC. Now when I was subtracting, I subtracted it thrice. So now the count of A intersection B has become how many? 0. But I need to count it at least once. So what we do is we again add it. So the formula says number of people in at least one of the three sets, that is union, is single add, double minus, triple add, alternate. A plus B plus C minus A intersection B, B intersection C, C intersection A, and the three intersection add. This is the formula and will only use if we want to find union. For everything else, we will use Venn diagram. Clear?
Yes, ma'am.
Done? Okay, let's read question number 11. We'll do it using Venn diagram. We will be doing it using Venn diagram. Huh? Let us first define the three sets. Let us first define the three sets. What are the three sets? People are talking about newspaper H, newspaper I, and newspaper T, right? So let A, B, C be the set of people who read newspaper H, newspaper T, and newspaper I, respectively. Okay. And now, once we have named them, we'll read the question, but we will do it backwards. Okay. So what I want to know is how many people read all the three? How many people read all the three newspapers? How many people read all the three newspapers? How many?
The center on the
No, I'm not asking you the Venn diagram. I'm asking you read question number 11 of ML Agarwal and you tell me from that information how many people read all the three newspapers. You see
Three
the
people,
last
ma'am.
line. Three read all the three newspapers.
Three.
So here I'll write three. Understood?
Yes, ma'am.
Now H and T both. H and T both. How many read both newspaper H and newspaper T?
ma'am 11.
How many people
11.
read both newspaper H and T? 11.
11.
That means in this shaded lens, there should be 11 people. But out of 11, I've already placed 3. So how many are remaining?
8.
8. Right? Then this portion. This is what? Common between H and I. How many read both H and I?
9.
9. 9 people read both H and I. But out of 9, 3 are already sitting there. So we are left with
6.
6.
6. Then this portion. How many read both T and I?
8.
8.
8.
Out of 8, 3 are already sitting. How many are left?
5.
5. So what are these 5 people? These 5 people read newspaper I. They read newspaper T, but they do not read newspaper H. What about these 8 people? These 8 people read newspaper H. They read newspaper T, but they don't read newspaper I. Do you all agree?
Yes, ma'am.
Okay.
Yes, ma'am.
Now we have done all the 3. We have done 2. We'll go for 1. So now you tell me in this H circle A, how many people read newspaper H?
25.
25. Out of 25, already 8, 3 and 6 are sitting. How many left?
8. 8.
8. So 8 will come here. Clear?
Yes.
Yes, ma'am.
Then newspaper T. Newspaper T. How many reads newspaper T?
26.
Out of 26, 8, 3 and 5 are already sitting. How many left?
10.
10.
Right? Then comes newspaper I. How many reads newspaper I?
26.
26.
26.
26.
Out of 26, 6, 3 and 5 are already written. How
12.
many left?
12.
12.
12.
12.
Done?
Yes, ma'am.
First, number 1, the number of people who read at least one of the 3 newspaper. At least one is union. So we could add all the 3 also if it is a 1 marker. Otherwise, if I want to write in newspaper, matlab, if I want to present it. So number of people in A union B union C. A, just write the formula. At least one is union. Now just add all the numbers that are present in all the 3 circles and tell me how many. Add all the numbers that are present in the 3 circles and tell me how many.
I'm 30.
30, ma'am.
No. No.
Ma'am, 77.
Okay. 8 plus 8 plus 3 plus 6 plus 12 plus 5 plus 10. 52.
52.
Yeah. Add all the numbers that are written in the circle. 8,
That's
8,
52.
3, 6, 10, 5, 12. If you add all the numbers that are written within the circle, we get 52. Yes or no?
Yes, ma'am.
Guys, understood?
Yes,
Yes,
ma'am.
ma'am.
All of you understood?
Yes. Yes, ma'am.
Yes, ma'am.
Yes. Yes, ma'am.
I haven't written ABC. I just wrote the formula and I added all the numbers in the circle. Formula was just for the namesake. Now, in your universal set, how many people were there? 60. And all the 3 circle combined is 52, right? So how many is not reading anything?
8.
8. Universal set minus union. But they didn't ask us. Second, number of people who read exactly one newspaper. So which portion was exactly one? Exactly A, exactly B,
8
exactly
and
C. So it will be 8 plus 10 plus 12,
30.
30. Understood, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes,
Any
ma'am.
doubt?
No, ma'am. No, ma'am.
Everybody clear?
Yes, ma'am.
Yes, ma'am.
Okay. Try question number 12, 13, 14, 15. Question number 12. Out of 20 students in a class, 12 like tea and 15 coffee. Assume that each one likes at least one. So 20 students like at least one. At least one is union. So A is the set of people who like tea. And B is the set of people who like coffee. So number of people who like tea is 12. Number of people who like coffee is 15. Union is 20. So we can use the formula N of A union B, A plus B minus intersection. So 12 plus 15 minus 20, that is 7. Yes. So my fault. This is 20. 12 plus 15 minus intersection. So N of A intersection B, 27 minus 27. So 7 people like both. Intersection is both, right? 7 people like both tea and coffee. Then number 2, only tea and not coffee. So number of people who like tea but not coffee, that is A minus B. So from the tea section, remove the common one. How many? 5? Yes. So if this would have been the circles, A, B, how many liked both? 7. Total there was 12. So 5. Here it was 5, 8, 15. So 8. So how many are only in the T circle? 5. So from the entire circle, remove the common one, that coffee shared. So 5 people like only tea. Yes. How many like only coffee and not tea? So this will be B minus. From the circle of coffee, subtract the common one. So from 15, let's subtract 7, that is 8. Therefore, 8 people like only coffee. Understood? Number 13. In a group of 400 people who speak either Hindi or English, there are 2 sets. So let H and E be the set. H is the set of people who speak Hindi. E is the set of people who speak English. Right? So at least either is union. 230 speak Hindi only. So if I talk about these 2 circles, Hindi and English, 230 speak only Hindi, this part, and 70 people speak both English and Hindi. Agree? And out of all of them, there are 400 people. So this is H minus E, 230. And N of H intersection E is 70. Yes? So if you see, this portion is what? E minus H, only English. So I can also use this formula. N of H union E is H minus E plus intersection plus E minus H. Yes. So 400, 230 plus 70 plus E minus H. So E minus H is 100. Right? So 100 people speak only English. Speak only English. Right? Yes. They didn't ask us English. If they would have asked us English, I would have added 70 also. Then it would have become 170. Any doubt, guys?
No, ma'am.
No, ma'am. No, ma'am.
14. In a group of 70 people, 45 speak Hindi. Let H be the set. 45. English, E, is 33. 10 speaks neither. So if there are a total of 70 people and we are saying these two are Hindi and English circle and 10 lies outside, 10 is in none of the set. So that means what? If neither, now universal set is 70 and none is 10. That means out of these two circles combined, how many should be? 60 remaining. So can I not say that H union E will be 70 minus none? That is 60. Yes or no?
Yes, ma'am.
Yes, ma'am.
So now union H plus E minus H intersection E. 45, 33 minus 60 is N of H intersection E. How many?
18, ma'am.
18. So 18 people speak both the languages. 18 people speak both Hindi and English. How many can speak only English? How do we find only English?
Ma'am,
N
B
of
minus
E
A.
minus
E minus H. So from English, subtract the common part. E is 33, subtract 18, we get 50. So 15 speak only English language. 15 speak only English language. Clear?
Yes, ma'am.
Yes, ma'am.
15. In a class of 35 students, 17 have taken maths, and then 10 have taken maths, but not economics. So if I talk in Venn diagram, this is maths, this is eco, and we are talking about a total of 35 people. That is universal set. 10 have taken maths, but not economics. So 10 is here. And in total, in the math circle, there are 17 people. So 7 should be here. So what is 7? Intersection, common. How did I get it?
6.
17 minus 10. So why not do that? M be the set of people who have taken maths. E be the set of people who have taken economics. So N of M is 17. N of M minus E is how much? 10. So therefore, N of M intersection E will be the difference of these two.
Yes, ma'am.
7. Yes. So 7 people have taken both maths and eco. From the entire math circle, I have subtracted only maths. Or you could think in this way. M minus E is 10. What is the formula of M minus E? M minus intersection. That is 10. Put the value of M, you will get intersection. Yes. Then each student has taken either of the two subjects. That means union is 35. All the 35 people have taken something or the other. Formula for union, M plus E minus intersection. M 17, E missing, intersection 7. So N of E 35 minus 10, that is 25. So 25 students have taken economics. But in the question, they did not ask us that. They asked us how many took only economics. So only in the economics circle to an entirety, I want 25 people. But 7 are already sitting. So 18 left. So these 18 are the people who are only present in the economic circle, and that is what I want to find. So how we will find the remaining number of people whose number of people or number of students who have taken only economics is from the entire economics, subtract the common part. So 25 minus 7, 18. There are 18 people who have taken only economics. There are 18 people who have taken only economics. Yes? Any doubts?
No, ma'am.
Ma'am.
Okay, can you
No,
move to
ma'am.
example 12? Example 12, the last example. It's a tricky one. In a university, out of 100 students, that means there is a total of 100 students. 15 offered only maths. 15 offered only maths. Then 12 offered only stats. 12 offered only stats. And 8 offered only physics. So there are 3 sets: maths, stats, and physics. Maths, stats, and physics. Right? 15 offered only maths here. 12 offered only stats here. And 8 offered only physics. Is this portion clear?
Yes, ma'am.
Now, 40 are offered both physics and maths. This portion I should have 40. 20 offered physics and stats. So this portion I should have 20. And 10 were offered maths and stats. But there is a problem. I can't write that 10. Because out of 10, 40 and 20, there is something common between all the three. Do we know that? No, we don't. Right? So what we need to do is we are not given that information. So we will assume that let X students opt for all three subjects. Yes. So automatically now in maths and stats, there were a total of 10. In maths and stats, there were a total of 10. But X people are already sitting. How many left?
Minus X.
10 minus X. Then in maths and physics, we have 40 people. Out of those 40, X are already sitting. How many left?
40 minus X.
A minus.
And stats and physics.
20 minus X.
So 20 minus X. So now we have filled all the regions, right? Yes. So by drawing a Venn diagram, find the number of students who offered math. So if they haven't said anything, so we assume that all the 100 people. Okay, we have been given another information. What? 65 offered physics. So in this physics circle, there should be 65 people, right? So given N of P is 65. So what can I make an equation out of it?
8 plus
Minus
40
X
minus
plus.
X plus 20 minus X plus X.
X equals to 65. Adding all of them, I should get 65. Simplify. What is X?
Is equal to 3.
X is 3. Right? We got X. Then, how many are offered maths? Number 1. How many are offered maths? So, in the math circle, we need to add and then put the value of X. Number of people in maths, 15 plus
15 plus
10 minus
10
X
Minus
plus
x
x
plus x.
plus 40 minus x.
Yes.
65 minus x. So put the value of x to be 3. That makes it 62. So 62 students offer mathematics. 62 students offered mathematics. Number of people who offered statistics. So n of s, that is 12 plus 10 minus x plus 20 minus x. So 42 minus x, 42 minus 3, that is 39. Yes?
Yes.
So 39 students offered statistics. Third did not offer any. So none. How do we get none if I get union? So first we will find out union. M union physics union stats. Add everything. Add everything. Add everything. So 105 minus 6x minus 6. 99. So 99 students have opted for something or the other. Right? So 99 students were offered something or the other. So number of students who did not offer any of the 3 subjects. What will that be? There were a total of 100 people and only 99 selected something or the other. So how many students did not select any?
100 minus 99.
100
Yes,
minus
that is
99.
what.
1.
So one student did not offer any of the 3 subjects. One student did not offer any of the 3 subjects. Is it clear?
Yes,
ma'am.
So with it, we are done with statistics. We are done with set theory.